All right, my friends. So sometimes after we do part A, people start freaking out that this is going to be super hard. So I'm hoping that if you memorize this piece here in the bubble, that you'll see that this is actually going to be very procedural, very quick type stuff. So basically what you need to do is find enough derivatives of your given function to where you've established the pattern. Typically 3 will do the job, and if 3 doesn't, then you just do 4 or 5. No big deal. So this is what I would do. I would just do, what's f prime, what's f double prime. So I'm pretending I haven't done part A. What's the procedure here? I'll go ahead and do f triple prime. There you go. Okay. And then I would plug 0 since this is Maclaurin. It is automatically centered at 0. And because this one is so simple, all the derivatives at 0 end up being 1. So this is procedurally kind of how you can go about these. And then you would just say, okay, well, the nth degree Taylor polynomial would be, and then you just put in f of 0, which is 1, plus f prime of 0 times x, which would be 1x, plus f double prime of 0 times x squared over 2, or 2 factorial, same thing, plus f triple prime of 0, which is 1, times x cubed over 3 factorial. Fourth derivative, actually, I didn't do it. So I would just go ahead and say, and keep going. And then you'd show when to stop. And with an nth degree polynomial, you'd stop when the degree of your term is n. And so by now you should notice a pattern that the power on x is, n, and then you're dividing by n factorial. There you go. And then you'd be done. Okay. But hopefully after me kind of making you do this the hard way in part A, you can see why the factorials need to be there. And if you understand why the parts of the formula are there, then it should make it a little easier to memorize it and not lose it along the way. Okay, so now let's go ahead and apply what we've learned, and using the method that we showed in part B, go ahead and play around with example 2. For part A, I'd like for you to see if you can find the fourth Taylor polynomial for f of x equaling cosine of x, which would be expanded about x equals 0. I suppose I could have called that a Maclaurin polynomial and saved myself a little writing, but that's the wording that they would use if they use Taylor polynomial type language. And then for part B, I'd like for you to show how to use your polynomials from part A, or your polynomial, that is, from part A, to approximate cosine of 1 and cosine of 2.